I'm focusing on the _is_classifier function from the scikit-learn library. It's a tool to check if something is a classifier. This is a multiple-choice question testing my understanding of how the _classifier function works. I need to choose which statements accurately describe how the _classifier function works in scikit-learn. The function checks whether a given object is a classifier. The _classifier function doesn't just look at the name of an object. It checks specific attributes to determine if it's a classifier. For example, it might look for attributes like _predict_proba_, which predicts probabilities, or _classes_, which means the model has been trained and knows different categories. In machine learning, an estimator is a general term for a model that learns patterns from data. Here, I'm focusing on whether an estimator is specifically a *classifier*, which means it predicts the category or class something belongs to. Examples of classifier estimators are things that classify emails as spam or not spam. Each statement in the multiple-choice question is either true or false regarding the behavior of the _classifier function. This statement is incorrect. I found that _classifier doesn't require the classifier to have been trained on data. It checks for attributes that indicate classifier functionality regardless of training status. This statement is correct. I discovered that _classifier examines attributes common to classifiers to make its determination. This is incorrect. I learned that _classifier uses more than just the name. It examines attributes that define how a classifier works. This is the main question of the quiz. I need to correctly identify which statements describing the _classifier function are true. It's a good test of my knowledge. I'm explaining the _classifier function from the scikit-learn library, a popular Python library for machine learning. This function helps us determine if a given machine learning model is a classifier. A classifier is a type of model that assigns input data to different categories or classes. This is a multiple-choice question about the _classifier function. We'll evaluate each statement to see whether it accurately describes how this function works. This clarifies that we're dealing with a multiple-choice question, not a true, false question or an essay question. So, I'm selecting the answers which are entirely correct. This reminds me that my task is to select the correct answers among the options provided in the quiz related to the _classifier function. I'm going to explain what the scikit-learn isclassifier function does. It's a tool we use to figure out if a machine learning model is a classifier, meaning it predicts categories or classes, like spam or not spam. I'll explain how it works. This is the question. We need to determine which statements are correct about isclassifier. Let's dive into each statement to find the right ones. This statement is true. The isclassifier function doesn't just look at the name of the model. It actually checks for specific functions within the model. For example, it looks for functions like predictproba, which gives the probability of a data point belonging to each class, or decisionfunction, which gives a score for each class. The presence of these tells isclassifier that this is a classifier. This is also true. Even if you create your own classifier, isclassifier can still recognize it as a classifier, as long as you've built it following scikit-learn's rules. This means that your custom classifier should have the necessary functions like fit, for training, and predict, for prediction. This statement is false. isclassifier doesn't just check the name. It looks for the important functions that define a classifier. This statement is false. The isclassifier function doesn't require the model to have been trained on data. It checks for the existence of the correct functions within the classifier, regardless of whether it has been fitted or not. I'm going to explain the _classifier function in the scikit-learn library. It's a function that helps you determine if a given machine learning model is a classifier. Think of it as a detective for your machine learning models. It investigates the model to see if it has the characteristics of a classifier. This question tests your knowledge of how the _classifier function works. We'll examine several statements to see which are true and which are false about this important function. Let's dive in. This statement is correct. The _classifier function doesn't just look at the name of the model. Instead, it looks for specific attributes or methods the model has. For example, if a model has a _predict_proba method, which gives probabilities for each class, that's a strong indication it's a classifier. This is like checking if a car has an engine and wheels, key features that define a car. This statement is also correct. Even if you create your own custom classifier, _classifier can still identify it correctly. The key is that your custom classifier needs to follow the standard scikit-learn rules for classifiers. This means it should have the necessary methods like fit for training, and predict for making predictions. So, it's not just about the name, it's about the behavior. I'll explain how scikit-learn's _classifier function works. It's not a simple yes, no answer based on the estimator's name. Instead, I will analyze the function's behavior and what factors the function considers. It's more like a detective investigating clues than a simple name check. I find this statement correct. The _classifier function doesn't just look at the name. It actively checks if the estimator has attributes like predict_proba which gives class probabilities, or classes_, which indicates that the model has been fitted and has learned classes. Think of it like this. If something quacks like a duck and * walks like a duck, it's probably a duck. _classifier looks for these duck-like attributes. Absolutely. I agree with this. Even if you create your own classifier, as long as it follows the scikit-learn rules, like having a fit method for training and a predict method for making predictions, _classifier will recognize it. It's all about following the established conventions, not just having a specific name. I see the function's inner workings. Scikit-learn's _classifier doesn't just look at the name of something. It's smarter than that. It checks if the thing has special attributes like predict_proba used for guessing probabilities, or classes_, telling us if it's already learned things. This way, I can figure out if it can actually classify stuff, regardless of what its name is. Let's say you make your own classifier. _classifier can still find it, as long as your custom classifier follows scikit-learn's rules, like having fit and predict methods. _classifier will recognize it as a classifier. It's all about those special attributes again. This is correct. _classifier does indeed check for attributes that usually go with classifiers, like predict_proba for probability prediction, or decision_function used for decision boundaries. It's the main way it identifies classifiers. This is also correct. I can create my own classifiers and _classifier can still spot them. As long as my custom classifiers behave like proper scikit-learn classifiers, having the right methods like fit and predict _classifier will correctly recognize them. The name of the class is not the most important thing. I see that this section focuses on how the function actually works. It's not just looking at names, it's actively checking if a machine learning model has the right tools for classification. Think of it like this. I wouldn't call a wrench a hammer just because it's a metal tool. I'd check if it can actually drive nails. Similarly, looks for specific attributes to confirm the model's classification capabilities. This part explains what looks for. It checks for specific attributes like, which gives probabilities of different classes, or, which gives scores indicating class membership. These are like hallmarks of a classifier. They show it's equipped to not just predict class labels, but also to quantify the confidence in those predictions. I find this a very important aspect of the function because it makes sure the assessment is thorough. This section highlights that can also recognize custom-built classifiers. As long as they follow scikit-learn's rules, having methods like for training and for making predictions, the function can properly identify them. This adaptability ensures broader compatibility. I think this is particularly useful for creating customized machine learning solutions. This line introduces the topic. We're exploring a function from the popular scikit-learn library that helps determine whether a given object is a classifier. We're diving into its functionality and logic. The question sets the stage. We need to identify which statements are true about the behavior of the function. This focuses the attention on testing understanding and factual recall.